So we're going to talk about mathematical operations today, addition and subtraction, multiplication, division. Because addition and subtraction do similar processes, they're just the opposites of each other, we're able to kind of combine rules. So rather than learning 4 rules, we're just going to be learning 2. Addition and subtraction, what we're going to do, we're going to be looking at the location. So we're going to look at the location of your sig figs. So we're looking at the smallest value here of digits. We want to use the smallest digits that are significant in all of our calculations. So the rules here are a little bit confusing, but we're going to help to clarify it. One of the big things with sig figs and mathematical operations, we're trying to separate this away from sig figs in terms of your calculator. When you do a mathematical operation, you're used to just plugging into your calculator and using that number as your answer, but that's not the case. Your calculator doesn't use sig fig rules. You have to know your sig fig rules. So if we take a look at the first problem here, we have 12.7, we have these values that we're adding together that will add up to 147.283. Quite often, I'm going to do the calculator part for you. What you need to do is take that value and round it to the appropriate number of significant figures. So the first and second number have 4 significant figures. Anytime you have a number that's not 0, it's going to be significant. So both of these have no zeros included. The only time that sig figs are a little bit confusing is when you determine if a 0 is significant or is not significant. So if we take a look at the last one, there is a decimal point. We're going to start on the left, work our way right. The first non-zero is the 4, and then all of the remaining values are considered significant. So I'm going to take a moment and highlight all of the significant numbers to make this easier. You'll notice that the numbers are aligned by the decimal point. I do that so that it's easier to identify the location that has a significant figure in all 3 values. So in this problem, I need to find the smallest location or the smallest column in my chart that has a significant digit in all 3 numbers. The tenths location has the smallest digit that has a significant digit in all 3. So I just highlighted those in green. All of those tenths are significant. So then what we're going to do is we're going to look at our calculator answer, which we got 147.2. So we're going to round to the tenths location. When we round, we have to take a look at the next number to determine if we round up or round down. The 8 rounds up, so the answer here ends up being 147.3. Now this number also has 4 significant digits. That's just a coincidence. That's not always the case here. We know it's to the tenths place because there's a significant digit in the tenths place in all of the values. In the next example, we have 900 with a decimal point. Since there's a decimal point, we're going to start on the left, find our first non-zero, which is 9, and then the other 2 zeros are also going to be significant. So this number has 3 significant figures. The next number follows the same pattern. It also has a decimal, so it ends up having 4 significant figures. The last number also has 6. So these numbers all had decimal points, so we started on the left, worked our way to the right to figure out how many significant digits there were. So what we need to determine now is what decimal point do we round to. So the easiest way to do this is to take a look at the number that has the least number of decimal points. So if you take a look, 900 has no decimal points, so its smallest significant digit is in the ones location. Because of that, we have to round to the ones location. So we're going to end up rounding to the ones. So we look at the next number is a 0, we round down, we end up with 1371, which happens to have 4 significant figures. So sometimes You'll have no decimal points, and you will have to round to the ones. Sometimes you could even have to round to the tens or the hundreds place. It just depends on the problem. So in the last one is a subtraction problem following the same pattern though. We have 5 significant figures, 5 significant figures, and 2. So the last one, we have some zeros that are being placeholders to keep our 8 and our 9 significant. We need those zeros to act as placeholders, otherwise we're going to be changing the value. So with our significant digits, we need to figure out where we need to round to. I need to round to the thousandths place because of the 8 here. The 8 is in the thousandths, and the other two numbers have their smallest significant digit in the thousandths place, so we're going to round that. So in this case, we're going to round to the 6. So we'll have 22.976, which is going to be 5 significant figures for this problem. So the quantity of significant figures, it just depends on where those significant figures are located. So that's why I always say addition and subtraction is based off of location. So the next set of rules is for multiplication and division. So multiplication and division have their own rules for significant figures, which are slightly different from the previous. Keeping in mind, addition and subtraction rules are generally a little bit harder than multiplication. However, multiplication and division rules can end up being a little trickier in some cases. What we're going to do the mathematical calculation, round off to the same number of significant figures as the values of the problem with the least number of significant figures. So addition and subtraction, we go by location. Multiplication and division, we go by quantity. So we're looking at quantity for multiplication and division. So what we're going to do, we're going to figure out how many significant digits we have, and then use that value to round our answer. So taking a look at our first example here, we have 34.91 times this very small number. So we have 4 sig figs in our first value and 2 in our second. So what we're going to do, we're going to round to the least number. So we need 2 sig figs in our answer here that's rounded properly. So we always take the 2 biggest sig figs. So in this case, we would take the 1 and the 8. But we have to round. We can't just leave it at 1.8. We have to take a look, what's the next value? So the next value is a 5. So we're going to end up rounding that to 0.19. That's going to be our answer with the appropriate quantity of significant figures. If you wrote 0.18, it's not rounded properly. It has to be 0.19. In the next number, we have 4 and 3, so we're going to round our answer to 3 significant digits. So we're going to do the same thing. We're going to take the 3 biggest significant figures. Now in this problem, we're going to end up with 15.7. The 7 remains a 7 because the next number right next to it is a 4. Even since it's a 4, 4 and below round down, so we stay at 15.7, which is 3 significant figures. So 5, this problem is a little tricky. It's practicing some of the sig fig rules. We have the 5 with a lot of zeros that has 7 significant figures, and 2 with 4 zeros, which has 5 significant figures. So because of that, we're going to use 5 for our answer with the correct number of sig figs. But the problem here is that our calculator is saying we have 10. So 10 only has 1 significant figure. We need to make it have 5. So what we're going to do, we're going to add a decimal point and then add zeros. The only time you can add zeros is if there's no number there. That's the only time you can add zeros as significant figures. So in the one above, you could not just make it 16.0 because you're taking away the numbers. If you have a number, you want to use it for the value. You don't want to just add zeros on to make your life easier. You can't do that. The only time zeros can be added is if there's nothing else there, like in this problem. So in the next problem, we're dividing by 2. We end up with 12.188. What we're going to do, we need 1 sig fig. So our first sig fig here is the 1. But we can't leave it as 1. 1 Whenever we're rounding with sig figs, we want to keep approximately the same value. So for this problem, we need to have a placeholder 0. That 0 makes it the value of 10. So it's holding the place of the 1 to keep it approximately the same value. The overall goal of sig figs is not to drastically change your answer. The goal is to keep it approximately the same and communicate the appropriate accuracy and precision of the instruments that were used to measure it. The last little bit of sig figs is taking a look at combination operations. So what this is when you have both addition and multiplication. So if you have addition and subtraction, it's not a problem, or multiplication and division is not a problem. It's only a problem when you have both. So what we're going to do, in this problem we have parentheses. We're going to do parentheses first. We're going to do 5.2 subtracting the 0.2, which ends up being 5.0 with sig figs. We're going to keep both of those because of the 2's are both significant figures, so we would round to the 10th place. So we keep the 5.0, so we would have 5.0 times 7.00 times 1.00. So this is 2 sig figs, 3 sig figs, and 3 sig figs. So with multiplication, we go by the least quantity, so we're going to end up with 2 sig figs, which would make our answer 35. Okay?